Hello, this video is Recitation 4. Our learning objectives are to demonstrate the basic probability rules, including addition, general addition, complement, independence, probabilities from contingency tables, and combinatorial probability. Task 1. In general, shopping online is supposed to be more convenient than going to stores. However, according to a poll, 87% of people have experienced problems with an online transaction. 42% of people who experienced problems abandoned the transaction or switched to a competitor's website. 53% of people who experienced problems contacted customer service representatives. What proportion of people did not experience problems with an online transaction? So here we would do 1 minus 0.87 because 87% of the people have experienced problems. So we're essentially taking the complement to basically find who did not experience problems. So that's going to be 1 minus 0.87, which gives us 0.13. What proportion of people experienced problems with an online transaction and abandoned the transaction or switched to a competitor's website? So the probability that someone abandoned or switched would be the probability that there were problems times the probability that they were abandoned given problems. So the probability that someone had experienced problems would be 0.87 because 87% of the people have experienced problems. And then the probability that they abandoned given the problems would be 42%. So that's 42% of the people who experience problems abandon the transaction or switch to a competitor's website. So when we multiply these together, we would get 0.37. What proportion of people experience problems with an online transaction and contacted customer service representative? So the probability that they contacted a customer service representative, CS stands for customer service, would equal to the probability that they experience problems times the probability that they contact customer service, given that they experience the problems. So experience the problems, or the probability that they experience problems is 0.87. And then the probability that they contacted customer service, given that they had problems, is 53% or 0.53 because these are the percent of people who experienced problems who contacted customer service representatives. So if we multiply these two probabilities together, we get 0.46. Task 2. Prior to the start of the season, suppose you randomly pick the first 3 places in the end of season rankings of the 10 teams in a conference. How many different outcomes are possible if the ranking, which there's 3 ranking, so there's first, second, and third place, is important? So here, we're going to be using this equation because order does matter. And so we would have N is the total number of teams and R is the number of places we are ranking. So we would have 10 factorial because that's the total number of teams in the conference, divided by 10, which is N, minus R. So R is, there's 3 places that we're ranking, first, second, and third. So it's essentially 10 factorial divided by 7 factorial. And so we have factorial is just that number times every number. So like n minus 1, n minus 2, and so on. So if you were to simplify, that's 10 times 9 times 8, which is 720. If each of the outcomes in part A is equally likely, what is the probability that you select the correct end of season outcome? So there's only one correct outcome. And then the total possible outcomes that we found in part A is 720. So we would just do 1 divided by the total possible outcomes, which is 720. How many different outcomes are possible if the ranking for second and third is not important? So here order does not matter. So we're going to do combination. So we have n factorial divided by r factorial times n minus r factorial. So the number of teams is still 10, and the number of rankings is still 3 for second, third. So we would have 10 factorial as the numerator, and then 3 factorial times 10 minus 3 factorial in the denominator, which simplifies to 3 factorial times 7 factorial in the denominator, which simplifies to 120. If each of the outcomes in part C is equally likely, what is the probability you select the correct end of season outcome? So similar to the previous one, we have one correct outcome, and the total number of possible outcomes we found in part C is also 120, so it would be 1 over 120. Task 3. An online retailer recently sent emails to customers that included a promotional discount. The retailer wonders whether there's any relationship between a customer's location in the United States, so Midwest, Northeast, South, or West, and whether the customer made a purchase with a discount. So yes, they made a purchase, or no, they made a purchase with a discount. The results are shown in the following contingency table. So here, the rows are whether or not they made the purchase, and the columns are the region. And so you can see that I created an extra column and an extra row to have the totals for each row and column. And we're going to use this information for the questions that will be asked. What is the probability that a randomly selected customer made a purchase? So we're looking at the probability of yes, which equals the total number of people who made a purchase divided by the total number of customers. So the total number of people who made the purchase, or total number of yeses, is 410, and then the total number of customers is 600. So we would do 410 divided by 600, which gives us 0.6833. So that's the probability that a randomly selected customer made a purchase. What is the probability that a randomly selected customer is from the Northeast? So here, we'll look at the Northeast column. And so the total for Northeast is 143. And then we're going to divide that by the grand total, which is 600 people. So 143 divided by 600 is 0.2833, and that gives us that probability that we were looking for. Given that a customer made a purchase, what is the probability that the customer is from the Northeast? So here we want to say, given that they made a purchase, so in other words, given yes, what is the probability that they're from the Northeast? So the probability of Northeast given yes. So that equals the probability of Northeast given yes. So we want to look in this cell, that's 102. And then divided by 410, because that's the total number of yeses. So that's how we deal with the conditional probability. So 102 divided by 410 is 0.2488. Given that a customer is from the Northeast, what is the probability that the customer made a purchase? So here, now the total number of Northeast is now going to be in the denominator. So if we look back, Northeast, the total number of Northeast is 143. That's what we're given. And then the probability of yes given that. So here, if we look back at how many yeses given in the Northeast, that's 102. So 102 divided by 143 gives us 0.7133. Are the events yes and Northeast independent? Explain using probabilities. So we found that the probability of yes given Northeast is 0.7133. That was part D. And then we also found the probability of yes, which is from part A, which was 0.6833. If they were independent, then these probabilities would be equal to each other, because whether or not it's from Northeast would not affect that probability. However, they're different from each other. So a purchase is not independent of a location. Task 4. You roll a fair die 2 times. What is the probability that you roll all sixes? So the probability that you roll 6 on one roll would be 1 out of 6 because we have a total of 6 faces and only one of those faces is a 6. And so that's for one roll, but we're rolling a die 2 times. And so each roll is independent. They're independent from each other. So we can just multiply these probabilities directly because of our independence rules. So we have the probability of 6 on the first roll times the probability of 6 on the second roll. So we already found the probability of 6 on one roll, which is 1/6. So we can do 1/6 times 1/6, which gives us 1 over 36, or 0.02778. What is the probability that you roll all odd numbers? So the probability that you roll an odd number on the first roll and the probability that you roll an odd number on the second roll, again, we still have independence, so we can multiply these probabilities together. And so there's 3 odd numbers on a die. That's 1, 3, and 5. So there's 3 odd numbers out of a total of 6 faces of a die. So that's going to be 3 out of 6 is going to be the probability of getting an odd number on the first roll. And then it's also 3 out of 6 for the probability of getting an odd number on the second roll. So because of independence, we can multiply these together. So we get 9 divided by 36, or 0.25. What is the probability that none of your rolls gets a number divisible by 3? So here, we want to find the probability of it not being divisible by 3 on the first roll times the probability of not being divisible on the second roll by 3. So here are the numbers that are not divisible by 3. We have 1, 2, 4, and 5. So that's a total of 4 numbers out of the 6 numbers on a die. So this would be 4 divided by 6 times, because of independence, and then 4 out of 6. So that's going to be 16 out of 36, or 0.44. What's the probability you roll at least 1 5? The probability that you roll at least 1 5, we can take the complement of that, which is 1 minus the probability of no 5s on both rolls. So that's going to be 1 minus, and then the probability of no 5s on both rolls. So we have 1, 2, 3, 4, and 6. So if we are not rolling a 5, we can roll any of these numbers. So there's a total of 1, 2, 3, 4, 5 numbers. So that's going to be 5 divided by 6 for the first roll times 5 divided by 6 for the second roll, and we can multiply these because of independence. And so we have 1 minus 25 over 36, which gives us 0.30556. What's the probability that the numbers you roll are not all 5s? So the probability that are not all 5s equals, we can take the complement of that because that's easier to compute. So that's 1 minus the probability of all 5s. So the probability of rolling all 5s would be, so there's 1 5 on a die out of a total of 6 faces. So that's going to be 1 out of 6 for the first roll times 1 out of 6 for the second roll. So 1 minus this quantity, which is 1 over 36, equals 0.97222. Task 5. 2 men, M1 and M2, and 3 women, W1, W2, W3, are in a chess tournament. Those of the same sex have equal probability of winning, but each man is twice as likely to win as any woman. Find the probability that a woman wins the tournament, and if M1 and W1 are married, find the probability that one of them wins the tournament. Hint, we're going to apply probability rules 1 and 2. So the probability that a woman wins, we'll define that as P. And the probability that a man wins, well, a man is twice as likely to win compared to a woman. So that's going to be 2 times P. So the probability, we want to make sure that these all add up to 1. So the probability that a man wins plus or M1 wins, so the first man plus the probability that the second man wins, plus the probability that W1 wins, plus the probability that W2 wins, plus the probability that W3 wins. That's going to be, so here we define, so M1, that's a man, so that's 2P as the probability. And then this is 2P. And then here we have P for each woman. And that's because we have, if they're of the same sex, they have equal probabilities of winning. So that's why we have 2P plus 2P, and then for the women, they each have P. So if you add those up, you get 7P. And because of our probability rules, we know that it has to equal 1. And so then if you solve for P, we get 1 over 7. So the probability that a woman wins equals the probability that woman 1 wins, plus the probability that woman 2 wins, plus the probability that woman 3 wins. So here, each of these probabilities is P, so that equals 3P. And we know that P equals 1 over 7, so 3 times 1 over 7 is 3/7. And then part 2 is if M1 and W2 are married, find the probability that one of them wins the tournament. So the probability that M1 or W1 wins is the probability that M1 wins plus the probability that W1 wins. So here we have 2P plus P. And so when we add those together, we get 3P, but we know that P is equivalent to 1 over 7. And so 3 times 1 over 7 is 3 over 7. So for part 2, we also get 3 over 7. Real estate ads suggest that 54% of homes for sale have garages, 31% have swimming pools, and 22% have both features. So use a Venn diagram to answer parts A, B, and C. So here on this left-hand side is for pool, and then on this right-hand side is garage. So pool, we were given that 31% have swimming pools, 54% suggest homes or homes for sale have garages, and 22% have both features. So this is in the intersection because they have both pool and garage. So what is the probability that a home for sale has a pool or a garage? So here, or we're going to be using a union. So that's the probability of a pool, P, union garage, G, which equals the probability of P plus the probability of G minus this intersection, because we don't want to double count the intersection. So that's going to be the probability of pool P is 0.31 plus the probability of garage is 0.54 minus the intersection, which is 0.22. That gives us 0.63. What about neither a pool nor a garage? So that's going to be the probability of pool union garage complement, which equals 1 minus the probability of pool union garage. So I'm forgetting a P here. This should be a P and then P union G. And so this is 1 minus. We had previously found the probability of P union G is 0.63. So that's 1 minus 0.63, which is 0.37. And then what is the probability that a home for sale has a pool but no garage? So that's going to be the probability of a pool minus the intersection of the probability of a pool intersect garage. So that's going to be 0.31 minus that intersection of 0.22, which is 0.09. And that concludes this recitation video.